A prime number is a positive integer that is divisible only by itself and 1. Some of these include 2, 3, 5, 7, 11, 13, and so on. It is not very clear when humans had discovered prime numbers, but it is estimated that they were discovered around 20,000 years ago. The first real evidence of the prime number theory was found on the Ishango bone, which is actually a 20,000-year-old fibula from a baboon. There are 3 columns on the bone with lines carved into them that look like tallies. The left column has the numbers 11, 13, 17, and 19, which are all prime numbers. Jean de Heinzelin was the first to consider that the bone was used for mathematical purposes such as some sort of calculator. Every whole number is either prime or a unique product of prime numbers. Since there are an infinite amount of whole numbers, there must also be an infinite amount of prime numbers that can create this unique product. In around 300 BC, Euclid proved through contradiction that there were an infinite amount of prime numbers. Another significant fact that was proven about prime numbers is how frequently they occur. After around 100 years of hard work, it took many mathematicians, including Gauss, Legendre, and Hadamard, to prove that of the first n amount of integers, approximately 1 on log n of them will be prime.
Modern cryptography is heavily based on mathematical theory, in particular the use of prime numbers. The factoring of large numbers into primes, for digits ranging into the hundreds, takes incredible amounts of computing time. As such, prime numbers play a key role in data encryption. Data encryption with primes is done by multiplying 2 large primes to create a massive number that computers cannot quickly break down back into primes, so preventing encrypted data being understandable for unintended receivers. There are many encryption algorithms which now use prime factorization. One of the most famous is the RSA system, named after MIT researchers Rivest, Shamir, and Adelman. RSA is one of the first public key crypto systems which takes advantage of prime factorization in computing, allowing people to send messages by encrypting them with the required public key, which can be deciphered by the receiver because it holds the primes multiplied to make this public key. A major application of this is in online banking. Prime numbers are also utilized in knot theory. One application of this is prime knots. Prime knots are essentially knots that cannot be decomposed further. This is applied in Schubert's theorem, which states that any knot can be written as a knot sum of 2 or more prime knots. Knot theory has applications in medical and biological research, such as DNA structures, and mathematical physics. Geometry and number theorem utilize prime numbers and theorems based around their properties to solve further problems. An example is Andrew Wiles using semi-stable elliptic curves which are reduced and studied at prime numbers to prove Fermat's last theorem.
Here is a video of a prime number calculator that tells you whether the number you have typed in is prime or not. It also gives you the reason why the number is not prime if that is the case.